Hello there guys, welcome back to the e-bike repairs YouTube channel. My name's Darsh and I take apart and fix very fun and exciting stuff. What I've got in today is a SANIK MRS 36 volt 9 amp hour battery pack. Now I've got the charger plugged in, 42 volt 1.8 amp output. When I plug the charger in I get lights of different varieties. When I unplug the charger, it all turns off. Oh, I've actually got a little red light. Well, do I have a red light? Maybe I don't have a red light. I don't think I do. Charger plugged in, press the thing, all sorts of flashy things occur, and yes, lights happen. Anyway. Second you unplug the charger, boom, all turns off. When I measure, there's a little crack on it just there, but that's a separate matter. And there's a picture of the sticker. Exciting. Yeah, when I measure the voltage on the output, so we've got an extruded aluminium housing, 2 plastic end caps. This thing definitely talks to the BMS. A couple of screws there. Probably screws underneath this, I would imagine. Lock slot there, charge port just there, and the output pins positive and negative over there. So when I measure the output, oh well, I've got voltage now. Interesting. Well, when I press the button, where's the button? There you go, you see it drops down to almost nothing. So when I press the button, it turns off. So, we've got like a load fault for some reason. Or something's broken. Anyway, let's pop the end off and have a little look. Today, to take this apart, I'm using my surprisingly not awful AliExpress screwdriver. I've got a dull video on that, if you look it up. Got 1, 2, 3, 4, 5 screws here by the looks of it. There is a fuse there, which I'd like to open it instead of checking it. Be more fun. Long screw. Oh, that's going to take all day. I'm assuming that's mostly out. Nope. Very exciting. I'm sure this is riveting content for you all 6 of you. I normally use the impact driver to undo stuff like this because it's obviously it rotates a lot quicker. But I left it in the garage and I don't want to go to the garage right now. I apologise for the 1,000 fans, it's very hot, so I've got the air conditioning on, the inverters on powering the air conditioning, and the solar charger is charging up the battery bank, which also has a fan on it. Which is, and then I've got a fan cooling a charger, as in blowing on a non-fan cooled charger, and I've got a battery testing machine on, and also a fan cooling said battery while it's on the machine. Yeah, that's fun, isn't it? So all you can hear is probably. Okay. Loose! She's off. She's out. So, we have taken 5 screws out of this end. They look like maybe M3 or something like that. And they are kind of long. Put them over there so I can lose them. And then, have we got anything on this side? We do have things on this side. Now, I'm assuming I'm going to have to pop... Oh, snap my nail off. I'm going to have to pop this panel off here. In order to get the other half of the case out. Probably need Using some little prying tools, like maybe a Stanley behind. Pick. Okay. Yep, that part just pops off. There's another button there. A button you cannot push. There's a power button and then a capacity button or something. And then we can see our other screws. So 1, 2, 3, 4, 5, 6 screws. You know what, probably to make this a little bit faster for everybody, I'm going to put a bit in the drill. And then not everybody has to suffer the speed of the other screwdriver. Whilst it's very handy, it's slower than we want. Exactly the same as the other side, except we've got 6 screws because we're not avoiding the charge port with 1 screw this time. There we go. Ah, so it doesn't talk to the BMS. It's just got 2 wires. How exciting. I've got 4 screws, and these ones are shorter than the others, same size, shorter. I feel like I should have 2 more somewhere. Oh yeah, look, there they are, hidden. Okay, can I push the pack out or is it held in? It's held in with, you guessed it, silicone. My favourite. So to pop this out, I think we're going to have to remove that bit of foam off there. And the connector is on this side and it's held in with hot glue. Is the hot glue old and not really very stuck? Yes. Is that good? Yes. Because I can get it off easily. Ta-da! Very good, right. And then most of the hot glue seems loose, but I think that the silicone is not. Give that a little slice. Once again, we've got not too much silicone this time, enough to hold it in all 4 corners, little dabs. There's nothing wrong with that, I don't have a problem. You know, I hate it, but I'm completely okay with it. And then this side, we've got the same, probably 4 little globs in the corners. Come on, you. Yeah. Yeah, see, the old hot glue just doesn't really stay anymore. Get that bit of foam off. Yes, hot glue for everyone. You can all have some. Give that a little chop. Give that side a little chop. That side a little chop, and okay, now will it come out? Tappy tap. Yes, it will. Tappy tap is the answer. I'm just going to bash this on the edge of the desk. You won't be able to see, but believe me, you can hear. It's quite stuck in there, isn't it? Blimey. Keep bashing. She's coming. I've got a wet hand. There's water somewhere. It did get splashed with rain as I brought it in, so it could just be that. Wow, that's really in there. Incredible. Oh, I dropped it on the floor. Anyway, there's the inside of the extrusion. All good, fine. Looks like a bit of alley. There's the battery pack. I definitely did not just drop on the floor. Now it feels like it's coated in fiberboard, which it was. That's why I was happy to stab my knife into it. Let's get rid of the heat shrink. Smells a bit gross, but Doesn't smell like burning yet, which is always a good sign. Doesn't smell like leaky cells either. Right, so we've got our cable that runs down to this switch here. That runs from positive, which goes from the back of the charge port around to the fuse, and then that comes down here to the output through the fuse. It goes through the fuse and then round there to the discharge port. Negative wires go straight from the discharge port in there. This negative for our little power doohickey at the other end comes out of there, and our charge port wire comes from the other side of the charge port down and inside the pack. Obviously this lot will go to the BMS, apart from probably the positive. So let's keep on opening her up, have a look, see what we got going on. Hopefully something exciting. Samsung cells, 26Fs. I've got a funny feeling this pack is getting on a bit. Oh yeah, look. So we're not completely populated. We are probably 10S4P then, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups. We're using nickel angled ladder. We've got definitely hand built spot welds because they're not completely and utterly consistent, you know, like a machine that was designed to only build this pack all day long. Not there's anything wrong with that, that's absolutely fine. We've got genuine cells, Samsung 22F, sorry. So that I think they're probably not that new. And then BMS wise, it's up here on the other side. So let's pop that up there and see what we've got going on. Nice to see cell holders, it's all insulated, the balance leads are insulated from the rest of the pack. Heat shrink on the ends, all looks pretty neat. Lovely. It's nice to open up a nice battery. Sometimes you open things up and think, shit. How am I going to get you around the right way? Well, I have to turn all of you that way? Yes. The temp sensor didn't really seem to go anywhere useful, but it hasn't blown up, so that must be fine. Two layers of heat shrink going on here. Or just one? Maybe just one. Get off my BMS. Get off it, I want to look at you. Show me. Show me your secrets. It's a fight to get into this, isn't it? There you go. Right, so the BMS was upside down. Oh, I've just turned it upside down, should I say. Now that looks like that's got hot there. These would be the balancing resistors, I think, where they were. You can see the heat bled through the fiberboard. It should all be a uniform colour. It's clearly got a bit crispy. But they're resistors, they get hot, that's their entire purpose. And then BMS wise, we've got what looks to be not horrid. Yep, it's a BMS. 1, 2, 3. Only 4 MOSFETs. Lots of balancing going on. Temp sensor, JST, battery input, power out, which is great. The cable is on the correct port for the doohickey that tells you the charge level. Balance wires, charge port in, and the positive just ignores the BMS in its entirety. So let's pop this out of here, the JST, and we'll take a little look and see what the cells are like. What sort of voltages they're showing us, if they're good, not good. This is on the main negative, so that's that side, that's great. Power up the machine. This is the machine. Pop that on there. It's the larger JST. Oh, look at that. The cells are almost perfectly fully charged, but one group is down. We are out of balance slightly. 3.8 volts on group number 9. What I'll do is I'll swing, just put that in a way where it's not going to short out and explode. Stay. I'll swing you down. There you go. All perfect camera work. So we can see our, let's use not my dirty finger, shall we? Total voltage of the pack, 41.6 volts. Average voltage, maximum voltage, minimum voltage, voltage drop, that's there, that's our big number. We don't want voltage drop like that. Voltage here, we've got 4.2 volts the whole way across. Apart from group number 9, 3.831 volts, so that's a bit low. So I can use my machine to balance that pack up, that's fine, but let's take a look at group number 9 and see why that might have happened. To make sure there's nothing going on with it. And it should be this one here because that's group number 10. Group number 9 here looks fantastic. Don't see anything leaky, horrible. Now I can't check this side very easily because of the way the cell holders are. But often if it leaks you'll see some discoloration around the end of the cell. And I can peel it away slightly. Look, and it looks fine. It looks fine. There's no point, no immediate cause for concern. So I think the best thing to do will be balance it up and see what it does. Now, will the BMS fix itself with a reset, or I disconnect the JST, plug the JST back in, and then try out this doobery. Okay, this old hot blew off a bit. Where did it go? Where did it go? In there. Plugged in. Plugged in, please. There you go. No. No, it will not. So at our main positive to our battery negative, we should have 41.65 volts, pretty full. We've got 31 on the charge port, 8 volts on the power port. It's not putting out power, it's unhappy about something. Does it need the charger plugged back in to activate it? Now charger's plugged in. What do we see on the power? Between power and here. Nothing. Are we sure it's nothing? That's more like it. Yeah, 42 volts because the charger's plugged in. Unplug the charger. Nothing. And this lot is all powered from before the fuse. Yep. Okay, so we've got a problem with the BMS. The BMS is unhappy and the cells are out of balance. So what I'll do is I'll balance up the cells, I'll replace the BMS. The pack will work again. Then I will capacity test it. Now, will it hold its full 9 amp hour? I don't have a date for the pack. If the pack's getting on a bit, it's not going to hold its full 9 amp hour. But for the sake of £80 for a new BMS replacement, 20 quid for this, and a bit of a balance, will probably be all good to go. Hopefully. So yeah, if that was helpful, thank you. No, you're welcome. Thank you very much for watching. I'm not going to show any more of this because it's not that exciting. It will be me plugging the JST into this, pressing the go button, leaving it, replacing the BMS, doing a capacity test, seeing if it holds capacity. If it does hold capacity, it will be buttoned back up and put back together and given back to the customer. If it doesn't hold capacity, it will get resold and buttoned back up and given back to the customer. So it doesn't really matter. There's nothing exciting for anybody else to see. And we'll just leave this one like this. Thank you very much for watching. If this helped at all, please leave a like, comment, share, subscribe, become a channel member. $99 a month. I get a very, very, very small amount of that, but it does inspire me to keep making these videos. Thanks. I'll see you next time. Bye bye.